As we all know, stars begin their long life cycles as a nebula, a collection of gases, which later compress and result in the formation of a protostar. As the protostar's life continues, the temperature in its core will eventually become hot enough for nuclear fusion to occur, making the star into a main sequence star. After some time, the main sequence star's supply of hydrogen wears out, and the star begins to rapidly expand and cool, forming a red giant. However, there is a rare phenomenon which occurs between these two cycles that is very important to the astronomical community. These stars have six notable phases, three expanding and three contracting phases, that they go through and repeat over time in cycles. These phases and cycle have proven to be extremely useful in helping us determine the distance from them to Earth. These stars are known as Cepheid variable stars. Phase 1 of a Cepheid variable star begins with a large amount of gravitational force beginning to rise as a result from the core's previous collapse. Phase 2 describes the outer layer's compression into the now superheated core, which results to the star being considerably dimmer and radiating far less energy. Phase 3 of these stars shows signs of significantly higher internal pressure and temperature within the star, marking this as the end of the Cepheid variable star's contraction into its core. Phase 4 marks the beginning of the star's expansion of its outer layers as a result of the outer layers being pushed out of the core because of its extreme pressure. Phases 5 and 6 make the star seem like it is going to form into the red giant that most main sequence stars transform into. The cooling outer layers as a result of the previous expansion in Phase 4. And secondly, while this is occurring, the star experiences both a significant drop in density and a large surge in both radiation and apparent brightness as radiation from the outer layers begins to escape from the star's gravity. As Phase 6 ends, the star suddenly turns back to Phase 1. While the cause of this return is unknown, we've been able to derive many significant properties from these Cepheid variable stars and their interactions with the universe. One of these discoveries is named pulsation. As seen in the luminosity over time graph, Cepheid variable stars continuously go from points from extreme brightness to dimness. The extreme brightness is known as standard candle brightness, as every Cepheid variable star experiences high luminosity and doesn't vary significantly. Along with this, an equation was also derived from this luminosity over time graph. Apparent brightness equals luminosity over 4 pi distance squared. This equation allows us to measure the distance to these Cepheid variable stars, and even galaxies. To recap, Cepheid variable stars are rare, extremely luminous stars that we can derive distance from. They also have a very notable cycle, and most importantly,
Cepheid variable stars? Well, they're pretty cool.